Hey, Christina, you get the prize. You are persevering. I appreciate you sending that data. I just want to be sure you're getting 100% for your work, and I wanted to look at it because part of this class, this physics class, uh, is to analyze data, and I want to make sure we're doing it like correctly. Okay, and it's just feedback. You already got 15 out of 15 on this. Mental note, the Spring Lab, you've got one more part to look at data, and that's the K value, like changing the spring constant and see what the impact on the period is. And that's another 15 points on lab. Now just keep boosting your score so we can get 20 more points out of that. So let's look at this. The period is directly or negatively proportional to the mass of the pendulum, meaning you were like, it's got a negative slope. Okay, so I just want to look at it real quick. Okay. Now, I don't think I can, oh, maybe I can edit it, right? I look at this negative slope and I look at the value of the slope. 2.5 times 10 to the negative fourth. That is like close to horizontal, okay? We also have to think about the intercept. What's the intercept mean? So this is mass as opposed to a spring constant, so mass over here. As the mass gets smaller and smaller, and this is hard because I don't see 0, 0. Plotting 0, 0 with data is like essential. Don't break that graph. Always try to do that. And maybe I try to modify that. But the line hits, right, if it were 0, 0, maybe about 1.5 seconds, right? Well, if I have a really large, and that's like at 0. Like, so if I had 5 grams, and I'm swinging it, and it's larger than the mass of the string, I'm going to get close to 1.5 seconds. Well, let's go out to 500, right? 535, and I measure that, right? And it's 1.35. Is that dramatically different? And the answer is no. Usually when we've got data like this, I'm going to see if I could have an insert. I'm going to insert average, right? And I get 1.41. And then I'm just going to take the difference equals 1.41 minus that. Now I'm going to go in here and edit it because I need it to stay the same for all my cells. And then I'm going to copy it. So what it's going to do, it's going to take the average minus these cells over here. Those differences are really small, but we're going to look at percent difference. So that would be the difference divided by the average. So what's the difference from the average, right? And I hit that, and that is like right around 5%. So I'm going to go there again. I'm going to put some dollar signs to keep that cell the same. I'm going to copy it down like that. So the number itself, as far as percentages, I've got 5%. That's big, but not too big. I've got 0.6%, so small, 0.2%, or 1.7%, and 4%. This is all, you remember that 5% category? It's all within that category. And then I go back to that slope. It is essentially flat, which means that period for a pendulum is constant. Now I'm kind of going into this a little bit because I'm pretty sure they didn't talk about this on the AP test that you were working with, okay? So it's open game, the period of springs and pendulums. So I want you to understand that pretty well. So let's go back here. Directly proportional to the length of the pendulum, meaning you think it's linear. So let's look at linear. That's time versus angle. You said it doesn't impact it, and I'd say you are correct. Look at that. If I were to, oh, I forget how to add in this stuff. But if I were to look at that and customize it and get that, what is it, in series, that trend line, and then I'm like, let's get an equation, 0.01, pretty straight. Now you have 0.01 and said it was flat, and you had 0.0002, and you said there was a slope. So Just trying to be consistent. No impact on the angles, okay? We could do a percent difference on those. But here's where this one, right? I wish that you had looked at 0, 0, okay? Because you didn't plot 0, 0. I'm trying to think where I can do that. Minimum value, 0. Did it do it? And we have to think what's happening as I get closer and closer, right, to 0. If I had a half, right? Right now, if this were linear, right, and I go to series, and I go trend line, does it make sense that if I have a really short length, that I would have a period that's pretty similar to 5? You would see as you were going, they get shorter and shorter and shorter as far as that period, and essentially comes to 0. So what we end up getting is more, right, more of a square root relationship, okay? So I just want you to get that. Now, where did I put that? I'm going to go to AP Physics 1. Oh, gosh. Maybe I'll go to my desktop. And I'm going to go to AP Prep Documents and AP Physics 1 equation sheets. Okay, let's see if it'll open up. I probably should have just done preview. Okay. These are the two equations. Let's see if I can get that to enlarge. It takes a while to get PDFs. These are the two equations. T sub s is the period of the spring. And I'm really going into this because I don't know what your retake's going to be like. But it didn't have this stuff before, and this is so unique, right? It might cover it. I don't know. The period of a spring, right, has this relationship. It's proportional to the square root of mass. So on that data, you should get, well, I guess I should do it like this way. You should get the square root relationship if you plot 0, 0, okay? And then as far as the K value on the springs, and you're going to find this is that nested thing. First, you would have this inverse relationship, right? As the K value increased, got stiffer it got, the shorter the period it is. The longer, the less the spring constant, right? The looser the spring, the longer the period. Well, it ends up, you do that, 1 over the K value, you get this, I guess, the square root relationship. So it's 1 over the square root of K. Just trying to show those equations and get you in context with those. The equation for the period of a spring, or a pendulum, T sub P, very similar. I love this, 2 pi, and then the square root, but the factors that impact a pendulum, not release angle, just like spring isn't impacted by displacement, right? But it's also not impacted by mass, which is crazy, okay? It's just impacted by length, and then it's impacted by g, but there's no way we can test it. I can't take you to Saturn and do a pendulum experiment, and then to Jupiter, and then to Mars, and then to Earth, and then to Venus. We'd have to change that gravitational acceleration by changing where we are in the whole solar system, okay? So that's kind of cool. We can consider that constant. So the only thing that changes the length, or the period of a pendulum on Earth, is by changing the length of the pendulum. I think that's pretty cool. So I just wanted to go through that. I know that's long. Quite possibly last video of the year. Thank you for being someone who listens to that and works to the end. Thank you. Oh, happy summer.